how to find the resultant from multiple parallel forces. For example, in this scenario, you can see this motorcycle. So you have the 250 pounds passenger, and then 350 pounds rider, and then the chassis, the engine weigh about 400 pounds, and then the chassis is 450 pounds. Assume everything else other than the engine, and all these directions, all the distances from the front wheel is provided in this scenario. So now to calculate the resultant, it is very simple. They're all acting in one direction, so simply we can do that summation of Fy. That will give us the total resultant of these all these different loads. Not a big deal. However, force is not just the magnitude, it is also the direction as well. So in this particular scenario, it is very important. We want to achieve, say for example, 50-50 weight balance between the front and the rear wheel for a touring motorcycle like this. So in this scenario, are we really achieving that or not? So the location of this resultant 1450 pounds total weight is very important. Where the location of that force? Where is the line of action of that force? That is the not difficult, but that is the main thing that we are interested in this particular scenario. In addition, the total load. However, the handling, the comfort, everything depends on where exactly that load is acting between the wheels. Now assume that, say, because we don't know the directions, we are trying to find out. I'm just assuming some random direction. Let's say it's going to act somewhere like in this direction, and we don't know the direction. Say this is at a distance d. Now, we know from the Varignon theorem or moment principle that if you calculate moment for each of these component forces, that will produce the exact same moment as this resultant force. So the resultant force 1450 moment from, let's say we are taking moment with respect to the front wheel. So the resultant force 1450 pounds will produce, I will skip the unit, and that is distance d away. Now we can basically, that will produce the exact same moment of all of these individual components. So this 400 pound engine weight, which is 25 inch away from the front wheel, plus the 450 chassis weight, which is 34 inches from the front wheel, 25 plus 9, 34. And then we have the rider, which is 350 pounds, and the rider is, so if you add basically 25 plus 9 plus 8, that's total is I found 42 inches from the front wheel, plus the passenger weight 250 pounds, and the passenger is total, if you add all of these, that's the passenger sitting from the front wheel, so that will be basically 57. That's what I found. So 57. Now if you now solve for d, I found that is from the front wheel, it is 37.4 inches. Now see, the total wheelbase, the distance between two wheels is 64 inches. So to achieve a 50-50 weight balance, we need about 32 inches of, from the front and from the rear. But we found the distance from the front is 37.4 inches, and then so we did not really achieve that, and distance from the rear wheel is much less, 26.7, approximately 27 inches, so 26.66 inches. So that's from the rear wheel. So we did not achieve that 50-50 goals. However, most motorcycles, they're not ridden with the passenger. Let's say the passenger does not exist. So if you delete that passenger weight, so then the total load would be then 1200. So it's going to be 1200 times d, and then also the last moment does not exist. So the if you take all the moments, I found that D is approximately, with no passenger, that was 33 from the front wheel. I calculated that. Now generally, if you don't even consider the rider, just the motorcycle, you want to balance these loads, you can delete that as well. So if you apply the same way, so D I calculated without anything, just a motorcycle, the distance we calculated was 29.8 inches from the front wheel, so pretty close. Now, if the rider weight is, I did another calculation, instead of 350 pounds, if I use a 200 pounds rider weight, then it becomes the D I found. If we use a 200 pound rider weight, then I found the D was about almost 32, so 32.1. And then from the front wheel, that's what I found, using a 200 pounds rider weight and with no passenger. So to summarize this video, simply all these parallel forces, you can just sum all these forces to find the total magnitude of the force. However, to find the direction, you apply the Varignon theorem or moment principle. So the resultant force will produce the same moment as the component force, and then you solve for the distance to find the location of the force.